Have you ever pondered the limitations of our current electrical technology? In today's world, we are heavily dependent on electrical power. However, our existing systems are bound by the constraints of wired connections, which can be cumbersome and limit our mobility. Imagine a world where charging cables, power outlets, and extension cords are things of the past, where power can be transmitted over the air just as easily as we receive our Wi-Fi signals today. Currently, our electrical systems demand a complex network of wires, cables, and outlets. This not only limits where we can use our devices, but also results in a significant amount of waste. The maintenance and replacement of these components add to our environmental footprint. Moreover, wired systems pose safety risks, such as electrical fires and electrocution. What if we could break free from these wired chains? Enter the era of wireless power. Wireless power rests on the principles of magnetic resonance and inductance. Now, let's unravel those big words and understand what they really mean. Magnetic resonance and inductance are two key concepts that form the backbone of wireless power. To put it simply, these principles enable the efficient transfer of electricity through thin air, eliminating the need for wires or physical connections. Let's break it down a bit more. Imagine two coils. One is a transmitting coil, and the other is a receiving coil. The transmitting coil generates a magnetic field, which is picked up by the receiving coil. This happens because the two coils resonate at the same frequency. It's like two friends on the same wavelength, perfectly understanding each other without having to utter a word. The transmitting coil is connected to a power source, and it generates a magnetic field as electricity flows through it. This magnetic field then induces a current in the receiving coil, which can be used to power a device. Voila! You've got wireless power transmission. Now you might be wondering, what's the big deal about resonance? Well, resonance is what makes this whole process efficient. When the transmitting and receiving coils resonate at the same frequency, it allows for a stronger magnetic field and therefore a more efficient transfer of energy. It's like tuning into your favorite radio station. You get a clear signal only when you're tuned to the right frequency. But don't worry, this doesn't mean that every device will start picking up energy from any random transmitting coil. The devices need to be specifically designed to resonate at the same frequency as the transmitting coil. It's a well-orchestrated dance, with each partner knowing exactly when and where to move. Wireless power is not just some fancy scientific concept. It's a technological marvel that's poised to revolutionize the way we interact with electricity. From charging your phone to powering your car, this technology has potential applications that can significantly change our lives. It's like having an invisible power grid, always there, always ready, and all you need to do is tune in. Imagine a world where cables and outlets become obsolete. This is the promise of wireless power, a technology that's not just about convenience, but about transforming our relationship with electricity in a fundamental way. Wireless power has the potential to revolutionize a variety of sectors. Let's start with the devices we use every day. Your smartphone, laptop, or tablet could be charged simply by being in the vicinity of a wireless power transmitter, eliminating the need for chargers and tangled mess of cables. Imagine your device charging in your pocket as you walk around your home or office, or your electric toothbrush powering up just by sitting in its holder. But it's not just about our handheld devices. Consider electric vehicles. Today, charging an electric car means finding a charging station and plugging in for several hours. But with wireless power, electric vehicles could be charged while on the move, on specially equipped roads, or while parked over a wireless charging pad. This could drastically increase the convenience and feasibility of electric vehicle ownership. And let's not forget about remote locations. Areas that are off the grid, where traditional power infrastructure is challenging, could receive electricity wirelessly, making life easier and more sustainable for communities in these regions. The benefits of wireless power go beyond just convenience. It's about mobility, about not being tied down by physical connections. It's about simplifying our electrical infrastructure, reducing clutter, and making our environments more streamlined and efficient. But these benefits go even further. By eliminating the need for physical connectors, we could potentially reduce the demand for material resources. This could lead to significant environmental benefits, as less material waste is produced and fewer resources are consumed. In essence, wireless power could be a key driver in our journey towards a more sustainable future. It's a technology that's not just about making our lives more convenient, but about making our world a better place. But like all great innovations, wireless power comes with its own set of challenges. From transmission efficiency to electromagnetic safety, wireless power has its hurdles. Indeed, despite the remarkable advances, wireless electric power is not without its challenges. One of the most significant hurdles to overcome is the efficiency of long-distance transmission. While wireless power has proven effective over short distances, such as charging your smartphone or powering a drone, the efficiency drops significantly as the distance between the transmitter and receiver increases. This drop in efficiency means that, as it stands, wireless power may not be the most practical solution for large-scale, long-range power needs. In addition to distance, the size of the transmitting and receiving coils can impact efficiency. Larger coils can transmit more power, but they also require more space, which can be a limiting factor in certain applications. Therefore, striking a balance between size, distance, and efficiency is a complex challenge that continues to be a focal point of ongoing research. Now, let's talk about safety. Anytime we're dealing with electricity, safety is paramount. With wireless power, concerns have been raised about the potential impact of electromagnetic fields on human health. While the levels of exposure are typically low, there's still a need for thorough research to ensure that long-term exposure to these fields is safe. Regulations and safety standards also need to be established to guide the development and implementation of this technology. Interference is another concern. As our world becomes increasingly wireless, ensuring that these power transmissions don't interfere with other wireless signals, such as Wi-Fi or Bluetooth, is crucial. This requires careful management of frequencies and may necessitate the development of new technologies or standards. In summary, while the challenges are real and significant, they are not insurmountable. Researchers and engineers are working tirelessly to refine this technology, improving efficiency, addressing safety concerns, and managing interference. The road to widespread adoption may be long and winding, but the potential benefits make it a journey worth undertaking. However, these challenges do not overshadow the potential environmental benefits of wireless power. Wireless power could be our ticket to a more sustainable future. This is not just a whimsical thought, but rather a grounded reality that is gradually unfolding before our eyes. Let's delve into why this is the case. At the heart of the matter is the reduction in demand for materials and resources. Traditional wired power systems require significant amounts of copper for the production of cables and plastics for their insulation. These materials, while plentiful, are not infinite. Every meter of cable we can avoid using equates to a small but meaningful conservation of these resources. Now imagine a world where wireless power has become the norm. No more tangled wires at your desk, no more tripping over cables. But more importantly, less strain on our planet's resources. The savings may not seem like much at first, but when you consider the scale of global electricity consumption, it becomes clear that the potential for resource conservation is enormous. But there's more. Wireless power transmission isn't just about reducing our demand for materials. It's also about reducing our carbon footprint. How so, you might ask? Well, consider electric vehicles. One of the barriers to widespread adoption of electric vehicles is the inconvenience of charging, the need to plug in and wait. But what if you could charge your car wirelessly just by parking over a charging pad? This could tip the scales in favor of electric vehicles, leading to a significant reduction in carbon emissions. Furthermore, remember those remote locations we talked about earlier? Imagine bringing electricity to these areas without the need for extensive resource-intensive infrastructure. That's not just a win for access to power, it's also a win for the environment. In conclusion, the environmental implications of wireless power transmission are profound. By reducing our reliance on physical materials and facilitating the shift towards cleaner energy sources, wireless power could play a pivotal role in our journey towards a more sustainable future. So, what does the future hold for us with wireless power in the picture? Well, a cleaner, greener, and more connected world perhaps. And that's a future worth striving for. A future powered by wireless electricity could transform our lives in ways we can't yet fully comprehend. Imagine a world where power cords and charging cables become relics of the past, where your devices are charged as soon as you step into a room, where electric cars charge up while waiting at a traffic light. This is the world that wireless electric power could bring to life. Beyond convenience, this technology has the potential to contribute significantly to sustainability. By eliminating the need for cables, we could reduce demand for materials, promoting environmentally conscious practices. And with the ability to power electric vehicles without physical connectors, we could cut carbon emissions and drive towards a cleaner future. The possibilities are as endless as they are exciting. As we continue to refine this innovation, the future of electricity transmission without physical limitations is on the horizon. As we continue to push the boundaries of electrical technology, the promise of a connected and sustainable world becomes more tangible.